Correlation and linear regression. Correlation analysis is a statistical technique used to measure the relationship between variables. So it is a numerical measure, meaning that we will get the coefficient of correlation. Okay, so the value of coefficient of correlation or correlation coefficient gives us the measure of direction and also the strength of the relationship between the variables. And it is important to note that the coefficient of correlation does not tell us about the causality between variables. Example, we have a sample of 10 households with their weekly consumption expenditure and also the income. So here assume that our X is income and our Y is expenditure. So when we want to see the correlation between income and expenditure, we want to see the relationship between these two, the direction of it and also the strength of it. So we are not saying that X causes Y or Y causes X because correlation does not imply causality. Pearson coefficient of correlation or simple correlation denoted by the letter R measures the strength of linear relationship between the two numerical variables. So it is looking at the linear relationship, not any other relationship, not quadratic, not cubic, but linear relationship between two variables and its strength. So it assumes that each pair of variables is bivariate normal. So this is the formula for correlation coefficient, whereby R equals to Sxy over Sx times Sy, whereby this Sx and Xy is the standard deviation of samples from X and also from Y. And this is the formula for Xxy. In terms of correlation, we have positive correlation, negative correlation, and also zero correlation. So when we have positive correlation, meaning that as one of the variable goes up, another one also goes up. If one variable goes down, another one also goes down. That shows a positive correlation. But when you have a negative correlation, it works vice versa, meaning that when one variable goes up, another one goes down, or one variable goes down, another one goes up. So that is in terms of the relationship. But in terms of the strength, so we will have a perfect 1 at the extreme right and also minus perfect minus 1 at the extreme left. So here is a perfect positive correlation. This is a perfect negative correlation. And here we say moderate positive correlation and also moderate negative correlation. So values of R closer to 0 indicates weak correlation. Values of R close to +1 or -1 indicate strong correlation. So the strength of the correlation using Evans 1996 suggests looking at the absolute value. So we can also say the strength of it is very weak if it is between 0 and 0.2. So this is the absolute value of the R. If it is 0.2 to 0.4 is weak, 0.4, 0.6 is moderate, 0.6, 0.8 is strong, and also 0.8 to 1 is very strong. So going back to the example, we want to calculate the correlation coefficient between variable income and also expenditure. Looking back at the formulas, so we see to calculate Sxy, Sx and also Xy, we need to have summation of Xy, summation of X, summation of Y, summation of X, and then we square it, X squared, and then we sum it, Y squared, and then we sum it, summation of Y, and then we square it. calculating all this, okay, and then we place in the formula, we will get SXY, SX, and also SY. And then from this, we can calculate the Pearson coefficient of correlation, whereby it is Sxy over Sx multiplied with Sy. So we have 0.9548. So meaning there is very strong positive correlation between the consumption expenditure and also household income. Once we have the R, the coefficient of correlation, we can use hypothesis testing in order to test whether there exists linear relationship or no linear relationship between the two variables. So here we are stating the population parameter, whereby H now we are using the symbol rho. Rho equals to 0 and H1 rho not equals to 0. So when rho equals to 0 means there's no linear relationship. When rho is not equals to 0 means a linear relationship exists. So if we can able to claim there exists negative relationship or positive relationship, then we can state one-tailed test, meaning that we can state in H1 rho less than 0 for negative relationship and H1 rho larger than 0 for positive relationship. So this is the null hypothesis and also the alternative hypothesis for the Pearson coefficient of correlation test. So what is the test statistic? So the test statistic here is the T star, whereby it is equals to R. R is our coefficient of correlation times the square root of n minus 2 over 1 minus R squared. So once we have the value of R, we can always replace in this formula and get the calculated T star. So once we have the calculated T star, we can always compare with the critical value. So this T star is following the T distribution. So for two-tailed test, we reject H now if it is false in the rejection region, meaning larger than the critical value or lesser than the minus critical value. And then right tail if it's larger than T alpha n minus 2. This is not alpha, it should be alpha over 2 because it's a two-tailed test. But this is alpha and this is alpha because it's a one-tailed test. And this is the decision rule. So from the previous example, we conclude that there exists a very strong positive linear relationship between the two variables based on the value of the coefficient correlation. But then if we want to make a statistical test of it, we want to conclude that there exists positive linear relationship between the two variables, and then we can do a formal test, a statistical test, by stating the null and the H1 and then the test statistic, the critical value, and then the decision. So H null rho equals to 0, H1 rho larger than 0 because we are claiming a positive linear relationship, and then test statistic is 0.95 multiplying the square root of n minus 2 over 1 minus r squared. So we have here 9.085, and then we need to compare with the critical value. So the critical value here is going to be T alpha n minus 2. So here n is 10, so minus 2 is going to be 8. Alpha is one-tailed test, so we just straight away use 0.05. So you have from the T table 1.86. So this test statistic is larger than the critical value, so therefore we reject H now. So when we reject H now, we are saying that statistically there exists a positive linear relationship between consumption expenditure and also household income.